But let's look at leg ulcers. So this is a leg ulcer. I don't know if you can see this from back in the back, but this is the sample type. This is our level 1. Level 1 is our PCR. So level 1, we're looking at a panel of microbes. Again, PCR is the older technology. You build a panel or primers for each microbe you want to look at. And we also do the bacterial load. So doctors ask me, well, how do I use this report to make clinical decisions? The first thing you want to look at is the bacterial load. If we tell you there's a high bacterial load, that's kind of your first flag that you have a problem. All wounds will have bacteria, but the higher the load, the greater the barrier to healing. If this report came back at 10 to the third and you took the dressing off and you looked at the wound and the margins were coming in, there was no drainage, then you say, guess what's happening? The host is winning. And whatever you're doing is helping the patient and the host factors overcome it. But if it comes back at 10 to the 7th, I guarantee you, if you take that dressing off, you're going to see a lot of drainage and that those margins are not moving, this wound is stalled. And that's kind of like the first aha moment where, okay, we got a problem. Then we go and we found Pseudomonas. So we look for 8 microbes. Of course, you've all seen Pseudomonas in your culture reports. We look at it as one of our primers in our PCR. And we're going to tell you this next day. We're going to tell you the load of bacteria and if we find any one of the 8. We found Pseudomonas and it was a 10 to the 6th. That's a lot of Pseudomonas. You could then take and put this patient on Cipro or Levaquin or another anti-Pseudomonal and then wait till our level 2 results come by. Now, the level 2, the full sequence is going to take 3 to 5 days. So in 3 to 5 days, we find everything. Well, you see Pseudomonas is in the wound, but I don't know if you can see it from back there, but the percentage of Pseudomonas in this community is 5%. So it's really not the big dog in the community. It's in there, but it's not the dominant species. The dominant species is Fusobacterium at 63%. I'm not sure any of you have seen Fusobacteria in your CNS reports, but again, it's an anaerobe. So we don't just give you this list and say, hey, go Google these and figure out what they are and figure out how to use them or what to kill against antibiotics to use. We provide a second page of the report which shows you the species, the percentages. Is it a gram-negative or gram-positive? Is it an anaerobe, aerobe, facultative anaerobe? And then what research shows which antibiotic is effective against that species. Now you're going to say, well, that's not a sensitivity, and my patient's Pseudomonas is different than another patient's Pseudomonas in a different hospital. And you're right. The problem with sensitivities is, one, what do you have to do a sensitivity? You have to grow it. So if you didn't grow it, then you never got a sensitivity. So you're getting back culture reports that grow maybe 30 to 40 bacteria. Well, what about the other 3,970 that we find in samples? You're not getting sensitivities. You're better off knowing what's in there. The other thing is the sensitivities, I'll talk in more detail, but they're done, when they're done in the micro lab, they're done on planktonic bacteria. They're never done on the community. So you don't really know the break point to determine sensitive S, I, or R on a community. You know it on a single cell bacteria, but that bacteria didn't come out of the host by itself. It was surrounded by other bacteria. So the issue that we get asked a lot about is, okay, are all these microbes, do I really need to worry about these? Are all these, quote, pathogens? The term pathogens is probably going to be modified or significantly changed in the coming years. And there's been papers in the journals now saying that we shouldn't even use it anymore. Because what we have here, again, is a collaborative community of bacteria. If all of you are bacteria and this whole room is a wound bed, some of you might be attaching to host cells and blowing them up. But we're all enabling each other because we're passing genetic material amongst each other and we're all helping each other. So you really, when you're talking about tissue and wound, you really want to take them all out. Now if I get into a debate with an infectious disease doctor and he says, no, I don't agree with that. I say, fine, if we can tell you the bacterial load in the wound, is that valuable? And they always say yes. And if I can tell you the dominant species in the wound, is that also valuable? And they usually say yes, because cultures are also looking for dominance. They're looking for dominance by what grows. We're looking for dominance by the amount of DNA we find. All right. Sensitivities, again, they're done on planktonic. This is your typical CNS report. There's also papers on this. The European Society of Clinical Microbiology and Infectious Disease, which is the equivalent to the American IDSA, published a guideline on biofilms and chronic infections. And they point out that the SIR results can therefore not be used to predict therapeutic success in the case of biofilm infections and offer no guide to clinicians for treating such infections. So they really don't have any value when you're dealing with something chronic. This is one of Dr. Erin Klein. She's local here in Chicago in the WILD group. They're using us. in her report, you can see over here MEC-A positive. Now when it comes to sensitivities, there are some sensitivities that are gene related. So Staph became MRSA because of a MEC gene. We can find that MEC gene the next day and report it to you. If the gene is in the sample, we'll tell you the next day whether your patient has MRSA or not. We can also find Candida albicans, one fungal species, and tell you that next day. But in level 2, we'll find a lot more. So in this case, she has MEC-A positive, she has dominant Staph epi, but then she has this Corneobacterium tuberculacum, which is a nasty one. And this does not grow in traditional culture. All right, let's talk about nails, because I think you'll find this interesting because you were taught and trained that T. rubrum was the cause, and you're going to see now that our data is going to kind of upset things, because we do a lot of nail samples, and I have the database of over 10,000 nail samples, and I can tell you from a DNA perspective, what are we finding in nails? So 50% of our nail samples that come in had fungal species. As our numbers went up, when I first looked at this at 4,000 nails, we were at about 59% of the samples had fungal DNA. Now, 50% of the samples do not have any fungal species. You're looking at the nail in the clinic room and you're saying, it's classic, it's got to be. And you send it to us and we say, well, if there was fungus in there, we'd find the fungal DNA, and it's not in there. They're having that appearance because they also have a lot of bacteria. All of our reports I'm going to show you in a second, when we find fungus, a lot of fungal species, we also find a lot of bacteria. And then you're going to say, well, do I treat the bacteria? We'll talk about that too. So this is one of our nail reports. You can't see it probably, but down here are all the fungal species we found in this nail. T. rubrum is not even in here. So if you had used a PCR with primers of 5 fungal species and they all came back negative, then you'd be like, okay, well, what else is in there? We're going to tell you everything that's in there, and also the bacteria. So in 10,000 nail samples, T. rubrum is still your #1 fungal species, but it's only 38%. So these are all the other fungal species we find. But in total, we have found 1,300 fungal species in our nail samples. So what you've seen is only literally the tip of the iceberg.